In this problem, it says that John and Robin promised their 3 sons that they will each get to pick one spot within 500 miles of their home in City A to visit on their vacation, and their sons visited cities B, C, and D, and were given all the distances between every pair of cities. So in part A, it says to represent this traveling salesman problem with a complete weighted graph. So the complete part means that there is an edge between every pair of vertices. So the only possible choice is A here. Now the weighted part is that there is a number attached to every edge. So that is our complete weighted graph in part A, and we're going to use that to answer part B. In part B, it says to use the brute force method to determine the shortest route for the family to complete their vacation. So I'm going to zoom in here so we can see this graph a little bit better. Let's do that. Okay. So with the brute force method, what I'm going to do is I'm going to start with my original vertex, which is A in this case, and I'm going to find all the different ways to travel through this graph. So I'm starting with A, and I could go to B. And from there, I could go to D. And from there, I could go to C. And then return to A. So that's one way of traveling through this graph. We're not traveling through every edge like an Euler graph or an Euler circuit. We're doing a Hamilton circuit where we just have to visit every vertex. So that's one route. So I'm going to erase that. Now what's another route? I always have to start at A. And again, I could go to B. And I don't want to go to D because that's going to give me the same result as I got last time. So let's travel along this diagonal. Let's see, we have B, and now we have C, and now I need to go to D before returning to A. So I visited every vertex, and there we go. So what are some other possibilities? Again, starting at A, I'm going to go to C this time. And then to D. And then to B. And then to A. So if I write these down each time, then I make sure that I'm not repeating the same route. And let's see, I can again go to C, and then to B. Write this down. A to C to B, and then to D, and then to A. Okay. So how many possible Hamilton circuits are there? Well, we have 4 vertices, and we take 4 minus 1, factorial. So 4 minus 1 is 3. 3 factorial means 3 times 2 times 1, and that's 6. So we already have 4. We should have 2 more. I have 2 where I went to B first. I have 2 where I went to C first. So now I'm going to have 2 where I go to D first. Okay. So A to D. Let's do D to B. B to C. And then C will go to A. Get rid of that. And then we have A to D. Now, last time we went to B, so now I'm going to go to C. So we have A to D, D to C, C to B, and then B to A. So those are my 6 roots. But here's the thing. They're not really all different roots, because when we look at going from A to B to D to C to A, this is going to be the same as going from A to C to D to B to A. So I'm going to take this, and I'm going to scooch it over here, and I'm going to pair that up with ACDBA, and I'm going to scooch that over to here. So those two go together. Oops. And let's see, what else do we have? We have A to B to C to D to A, and that's going to be the same as A to D to C to B to A. And so I'm going to select ADC and pair those together. And then finally, the last two go together. So here we have ACBDA, and this is the reverse of that one. So why do I want them paired up like this? Because then I only have to calculate the length of the root one time for each pair. So let's start with this group down here. So we're going from A to B, that's 304. B to D, that's 241. D to C, that's 277. And then C to A is 203. And I get 1,025. Okay, let's come back up to the top here. I'm going to erase this. And I'm looking at this group, A to B to C to D to A. Okay, A to B is 304. B to C is 493. Okay. C to D is 277. And make a a little space there. And D to A is 80. Let's see, what does this turn out to be? For that, I'm getting 1154. So far, this is the better route. We're saving about 125 miles that way, a little bit more than that. So now let's take a look at the last route. And I'm starting with A to C. And I could have done A to B to D to C to A. Either one route or its reverse. Doesn't matter which one. Okay, but we're starting with A to C, so now I need to go C to B. And that's the 493. And then we're going to D, which is 241. And finally to A, which is 80. And that gives me 1,017 miles. So my shortest route is going to be A to C to B to D to A, or A to D to B to C to A. And that is the correct answer. That's how you do that problem.